This week, we'll be touching on the Arrhenius Equation question. Part A of the question. Explain how Arrhenius law can be used to explain the temperature effect on the rate of reaction for an irreversible reaction. Based on your knowledge, rate constant equals the frequency factor exponential of activation energy over universal gas constant multiplied by temperature in Kelvin. Assuming K0 and EA is constant, higher temperature will result in a higher rate of reaction. To prove this, we'll rearrange the variables of the equation into ln K equals to ln K0 plus negative EA over R multiplied by 1 over T. Let ln K equals to ln K0 and negative EA over R be negative 1 and 1 over T to be 0.5 when T equals to 2 and 0.2 when T equals to 5. This shows that as temperature rises, rate constant increases. We can conclude with higher temperature, the energy barrier EA can be overcome easier and give a higher reaction rate. This is because, with higher temperature, collisions impact between reactants rises and thus bonds of reactants will break free to form new compounds. Part B of the question. Other than temperature effect, listen and explain two other factors that can affect the rate of reaction of an irreversible homogeneous liquid reaction. The two other factors are concentration and catalyst effect. Concentration. When concentration of the reactant is increased, the chances of collision between reacting molecules will increase, thus increasing the rate of reaction. Catalyst effect can be used to promote the rate of reaction and reduces the activation energy, thus affecting rate of reaction. For data given in the table below, determine the Arrhenius parameters using a suitable graphical method. To solve that question, we'll make use of the rearranged equation, which we can relate to the simple equation y equals mx plus c, where ln k is the y-axis, 1 over t is the x-axis. We can then determine the gradient of the line equation, which is negative EA over R. From there, we can calculate out the EA value, which turns out to be 113.88512. From the graph, we can obtain ln K0, the y-intercept of the graph, which is 42.048. The result is then inversed to know the value of K0. This is the end of the video. Thank you for listening.